So in this slide, you see that all these information is deciding these many sample size. This is prevalence case. In a prevalence case, I need that what is the expected prevalence. So if I want to know that what should be the prevalence of obesity in
some university,
I want, for sample size calculation purpose, I must have some prior knowledge about the prevalence. So let's say that expected prevalence is 20%. So 0.2 is the 20%. Now, from this 20%, how much deviation, how much far away is acceptable to me? So this is 10%, 8%, 5%, 2.5%, or 1%. Now you see, the more closer I want to be, the more bigger sample size I have to pay from the assumed reality. It should be the true reality also. In the same case, I would like to explain with another type of scenario. So this is the computed sample size. If you want to do the research in a height, these are the computed. In a prevalence, these are the computed. But maybe sometime the suggested sample size is not feasible to collect or not budgeted to conduct. Then what to do? Then we will do a reverse calculation. And we fix the sample size as per the resource and budget. And we'll try to see that with the given sample size, how closer I can be with the reality. So let's say that I can do a sampling of 100 subject only. So this is somewhere here. So with 100 subject, maybe we are going to have 8% of the plus minus 8% of the boundary with the true reality. So case 2 is going to demonstrate based on the budget and resource. So what we need to know that budget, how many subjects we can recruit, and required some information about the parameter of interest, like what is the percentage, how much, what is the measurement magnitude, all those things. And then some statistical information like error margin, alpha, power, all those things. In a estimation process, power is never demanded. It's mostly applied in the hypothesis testing. But we must have to know the alpha for a boundary construction. So this distance, once we know the tolerance limit, we can plug. After plugging the number of sampling unit we can afford, we will get to know that what is your tolerance limit with this sample. And if that tolerance limit is acceptable, we can proceed the result. If that is not acceptable, better not to proceed for that result. We have to increase the sample size in that situation. So try to focus on the arranging some more fund for accommodate the appropriate sample. Now, moving ahead for hypothesis testing, the third pillar of our framework. So in the hypothesis testing, definitely we know something about the parameter and we have our own hypothesis on that. And then we want to test that whether my own knowledge is correct or wrong. So when going to construct the hypothesis, there is a null hypothesis and alternate hypothesis. There is no difference. Null hypothesis means there is no difference. Alternate hypothesis means there is a difference. Now for this also, we must have some understanding about tolerance limit, allowable difference, what is the significance level and confidence interval we want, and very, very important criteria, the distribution of the parameter of interest, whether it is normal or not. Now to understand more about testing of hypothesis and the type of error, this is a very well known diagram. You must have gone through this diagram in every single statistical classes you may have attended. So I assume that you have quite good knowledge about type 1 error and type 2 error. In the whole decision theory, there is a truth in the population. We take the sample. If from the sample we identify the same truth. So truth based on the population, true. And from our sample, what is it say? If it is saying the same truth, right, correct. In population it is false. From our sample also it is saying false. Here also right, correct decision. But if population is true and sample is saying false, then there is a error happening. If population is saying false and sample is saying true, there is a error happening. And there are two type of error basically existing. So we will keep in mind and will proceed further. In a hypothesis setup, probability of rejecting a true null hypothesis. True. Population wise it is true, but I am rejecting based on my sample is my type 1 error. Whatever this error computed from the statistics is p-value. Now, in a population means with our null hypothesis, reality is it's wrong. But from the sample we are saying acceptable. This is second type of error. And reciprocal of that means when it is wrong, when it is false, then I am able to say it is false. It means ability to take the correct decision. That is R beta. Probability of rejecting a false null hypothesis. If it is false, I am going to reject it. That's the ability of taking correct decision, and that's treated as a power. Now, once we understand this, let's come back to our estimation problem and then building a hypothesis. So we have taken a
Assam University
is height. Let's assume it is 163. I have assumed it. Now I want to test whether my assumption is correct or not. So for that, what I have to do? First of all, my assumption 163. And then I want to say that from 163 plus minus 3 centimeter is okay. So this is my allowable difference. I am okay with this difference. And variability is 12. Now I have built a hypothesis. My null hypothesis is average height is 163 centimeter. What is alternate? It is not 163 centimeter. So to test it, we need a Z test. And Z test means normal test, I can say. From the Z test, we will be able to compute the sample size. So before proceeding to the sample size calculation, we have to check few assumptions. Does our parameter of interest, here is height, follow a normal distribution? Luckily, yes, height follows that. If not, then we are in trouble. So what we have to do? We have to find the closest distribution of that parameter of interest. Suppose I am studying time to event. Maybe it follows a Cauchy distribution or Bevel distribution or some other distribution. So if it is not, we have to find the approximate distribution, and then we have to proceed, or we have to convert that distribution into normal and proceed. Like PK data, mostly it is follow log normal distribution. So let's go ahead with the normal distribution, height follow that, and we want to proceed. Here is a screenshot of a software which computed the sample size for us. Now in this slide you can see my type 1 error alpha fixed at 5%. I want to build a hypothesis two-sided plus minus. Null hypothesis which I have taken mean equal to 163. I have taken Sebrum column just for demonstration so that you can understand that how much difference is important. What is alternate hypothesis? So if my allowable difference is 10 unit, this will become 173. If it is 7 unit, 170. So for different allowable difference, I have constructed alternate. Standard deviation is 12. And then these are the sample size with the given power. So power also I have to fix, then it will give me the sample size, or I have to fix the sample size, it will give me the power. Now in this, just for demonstration purpose, you can see, this is the fixed standard deviation, 12, 12, 12. What is changing here? The allowable difference, 10, 7, 2. So if the allowable difference is more, we need lesser sample size. Allowable difference is less, we need bigger sample size. So we can see that if the allowable difference is lesser, the bigger sample size, and bigger the allowable difference, the lesser sample size. Now let's fix the allowable difference with 2 and 2. Now see what is happening by the standard deviation. I reduce the standard deviation, my sample size reduce. So 2, 2, 2, 12 standard deviation, 379. Increase standard deviation, sample size increase. Decrease standard deviation, sample size decrease. So this is the relation between the allowable difference and the standard deviation, and both have a strong impact on your overall sample size. Understanding the sample size with two groups. Now I have explained single group. Now let's say two groups. One is
Assam University
and one is
Delhi University.
Now I want to test whether average height of
Assam University
and
Delhi University
are same or not. So for this I have constructed a hypothesis that height of
Assam University
are equal to
Delhi University.
There is no difference, absolute no difference. My alternate is there is a difference. Now what is the allowable difference? Even with that difference I will say that both are equal.